Okay, I'm going to go through a few of these problems to make sure you're able to get on your way. I'm going to start with number 3. This is an arithmetic sequence, so our formula is this. And so on number 3, we know our first term, we know d, and we know n, so we're looking for the 73rd term. That's what they're asking us to do. So you start with your first term plus what it is that you're adding every time. I'm going to the 73rd term, so it's 73 minus 1. And then I can just plug that in the calculator. You have a total of 992, so your 73rd term would be 992. Number 5, this is just the generic nth term. So find what a sub n is. So you plug in your first term. It looks like we're adding 14 every time, times n minus 1, and then I want you to go ahead and distribute. So 64 plus 14n minus 14, combine your like terms. So we end up with a 14n plus 50. So that would allow you to find any term you want now. Arithmetic mean. So we started with 235. But I'm going to add d. I'm adding the same number over and over again. Let's find out how many times. So there's one step, 2, 3, 4, 5, 6, 7. I added d 7 times. And when I did that, I ended up with 32. And so now I'm going to solve that equation. I would subtract the 235 from both sides and divide by the 7. And I see that d is negative 29. Now I can go ahead and actually subtract 29 each time to find those missing terms. So subtract 29 from the 235, giving us 206, and then 177, followed by 148, 119, 90, and finally 61. If you were to subtract 29 from 61, you would end up at the 32. To confirm that, yes, we did in fact do that correctly. Sum of an arithmetic series. So we'll use that formula. So our number 9, we don't know which term it is. So we need to know, the three things we need to know are a sub 1, a sub n, and n. Let's think about what we actually know. We know what the first term is, it's negative 4. We know what the nth term is, it's 91, but I don't know which term that is in the sequence. So I have to first figure that out using my sequence formula from above. So my nth term was 91, my first term was negative 4. My d looks like I'm adding 5 every time, so 5 times n minus 1. So we'll do this to figure out what d is. So now I see that n has to be 20. Now I know all the pieces that I can find the sum. The sum of these 20 pieces is 20 times the average of my first and last. And you end up with a total sum of 870. 10 is like that. 11, 12, 13, you can plug those in the calculator. We've talked about that. So I want to show you that one. Number 14, here I know what the sum is. They want us to find the first 3 terms. To find the first 3 terms, well, I know the first term already, sorry. But I need to know what I'm adding each time. So first thing I'll do is use the sum formula like we just did. Plug in what we know. So this total sum is 100. I don't know how many terms there are, so I'll leave the in there. But I know the first term. I know the last term. So I can find their average. So the average there is 10. So 10n equals 100. So n must be 10. Now I know that 19 was the 10th term. You can write it this way if you'd like. The 19 was the 10th term. Now I can go ahead and find out what d is using the sequence formula. So a sub n, that's 19, equals your a sub 1, which is 1, plus d, I don't know what d is, times n minus 1, I now know n. It's 10. So plug that in. I'll subtract my 1, so I get 18 equals, that's going to be a 9d. So d has to be 2. So now I can go ahead and give the first 3 terms. The first term was 1, and then I'm adding 2 each time. Plus 2 is 3, plus 2 is 5. There's the first 3 terms, and so the next few of these are the same type of problem. Now let's go to the back side and look at geometric. So first of all, a geometric sequence. There's our formula. Number 18, they're asking for us to find the 5th term. They want to know when n equals 5, so let's plug things in. So my 5th term is equal to my first term times r, which is a negative 2 to the power of n minus 1. So 5 minus 1, which is really a 4 order of operations. Either plug this in your calculator right away, or be careful with your order of operations. Notice that we're doing negative 2 to the 4th power, then times negative 3. And so that gives us our 5th term, which is negative 48. Number 21, same idea, just find the nth term. Just stay in general now. First term was 2. Looks like we're multiplying by negative 3 over and over again. So there's my nth term rule. Geometric means, okay, so it looks like since this is geometric, I'm multiplying by r once, twice, 3 times, 4 times. I started at 1. I multiplied by r 4 times, leaving me with 81. So this is the same as saying r to the 4th is equal to 81. So we have to do the 4th root of 81. Because that's an even number root, I'm going to have to do a plus minus. So there's actually going to be 2 answers. And let me show you how to plug this in the calculator in case you don't know where that root is. So if you go to math, if you go to math, you have, looks like the 5th option down here, it's an x root. If you choose that, now you can put whatever root you want. So we want the 4th root of 81. So in case you weren't sure where to find that, I wanted to show you. We see that that's 3, but it was a plus or minus 3. So we need to consider both of these cases. So we're finding the geometric means. So let's first operate under the positive 3. If I multiply by positive 3, my first geometric mean is 3, and then multiply by 3 again, I get 9, and then 27, and then I have the 81. But now if I had multiplied by negative 3 instead, 1 times negative 3 is negative 3, then a positive 9, then a negative 27. So it could be either set of numbers, 3, 9, 27, or negative 3, positive 9, negative 27. 25, find the sum. We had 2 formulas. Really only going to need to use this one. This will work for each of these problems. So let's plug our numbers in on number 25. So the sum of these 8 terms is equal to our first term minus our first term times r to the nth power over 1 minus r. That you can plug in the calculator. Let me show you, just in case you want to. You can do some simplifying first, but we can plug it in. Just be careful. I'm going to do parentheses around the numerator. 360 minus 360, a new set of parentheses around my r, which is 4/3. Close that parenthesis to the 8th power. Now I'm done with the numerator, so I end that parenthesis. Divided by, and then a new set of parentheses around my denominator. 1 minus 4/3. You could put 4/3 in parentheses. It's not necessary because there's an exponent, but there's my sum. So 9,707 we'll call it 82. 26, 27, you can plug those both into your calculator, just like on the other side. Just make sure that you understand that whole thing, that whole rule will be in the set of parentheses on the calculator. Don't stop the set of parentheses after 5 and then start a new problem. Make sure that's all within one set of parentheses. Okay, and then number 28. Here we know the sum, so I'm going to plug this into the formula. The sum is equal to the first term, I don't know what that is, minus the first term again, still don't know what that is, times r, which is 5 to the nth power, which is 3, over 1 minus r, which is 5. Let's do a little bit of simplifying here. Okay, so I have a sub 1 minus, and that's 125 a sub 1 over negative 4. I could get rid of this fraction by multiplying by the denominator. So multiply both sides by negative 4. So we get negative 6,200. is equal to, and now look at this numerator. Those are like terms. That's like a 1 a sub 1 minus 125 a sub 1. So 1 minus 125 is negative 124 a sub 1. Divide by your negative 124, and I see that I get positive 50. That's what they're asking is a sub 1, so I'm finished now.